This is Honors Algebra 2 Pre-Calculus. We're doing section 9.2 in Pre-Calc, which is arithmetic sequences and partial sums. This is example 3. The third term of an arithmetic sequence is 15. The eighth term of the arithmetic sequence is 35. Write the formula for the nth term and then use it to find a sub 20. All right, so the thing here is that we don't, so if you think about the formula that we want, right, so the formula for the nth term, right, the formula we want for the nth term, so we're just going to come over here for a sec, is a sub n equals a sub 1 plus n minus 1 times d. Now that's great, except I don't know any of those things, right? In some of the problems that we've seen so far, we can easily spot the first term, we can easily spot the common difference. Well, here you don't have that. Now, there are a few ways to do this. One way to do this, if you feel more comfortable with a visual representation of this problem, is to literally draw out 8 blank spaces and put the number 15 in the third one and the number 35 in the eighth one and then figure out the common difference. And that's fine, right? So one way to do this is visually, and I'm going to walk you through a couple of options, right? So one way to do this, and I think I can maybe squeeze in 8 lines over here. We're going to try it. 1, 2, 3, 4, 5, 6, 7, 8. Okay, one way to do this is to say that the third term is 15, the eighth term is 35, and then I could figure out exactly how many common differences I would need to get from the 15 to the 35. I'm going to show you another way to do that in a sec. So I would need 1 common difference to get to the next term, 2, 3, 4, 5. I would need 5 common differences to get from one to the next, right? So 15 plus 5 of the common difference has to give me a 35, right? Well, that means that 5 of the common difference is a 20, so the common difference must be a 4. Now, the cool thing about doing this is if I choose to draw it out this way, I can now use this to fill in the rest of the values, right? So now that I know that common difference is 4, I can find the starting value by working backwards. I can say, okay, well, if I'm adding 4 to get from one term to the next, then go backwards in the sequence, I must be subtracting, so this must be an 11, and if I subtract again, this must be a 7. So I now, using that logic, could figure out that my a sub 1 is a 7, and I know my common difference was already a 4, so I can write my formula, right? So that's one way to do it. If you chose to do it this way, when you get your value, you get a sub n equals the first value, right, a sub 1, which is a 7, plus the n minus 1 times a 4, and that's great, okay? And then if I want, I can use that to find a sub 20, right? Now, again, if you want to distribute this, you can. If you do, you're going to get a 7 plus a 4n minus 4, so you get 4n plus 3. And if you do that, then a sub 20 is pretty easy to find, right? A sub 20 would be a 4 times 20 plus a 3, so that's an 83, right? So a sub 20 would be an 83. Now, that's one way to do that problem, and there's nothing wrong with it, right? The other way to do that problem is, let's say I had given you two values that were farther apart. So third and eighth isn't bad. With third and eighth, you can definitely go from there and figure out the values. But if I gave you values that were farther apart, it's a little bit difficult. So what's interesting is that this formula that we found already, the formula that we found by logic in the last video that's different from the textbook formula, actually applies to this as well if what you realize is that these are the two numbers that appear in here, n and 1. So if you wanted to find some random term, right? So if I want a sub 8, I can actually find it by saying I'm going to start at a sub 3, but that means I would need 8 minus 3 of the common difference, right? Just like this was n minus 1 of the common difference, and you can see that, right? Because I was on the eighth term from the third term, and sure enough, I needed 5 of the common difference. 5 because 8 minus 3 is 5. So if you recognize that, you could have jumped right to 35 equals 15 plus 5d, which is the same thing we got to by drawing this out, right? And so once I get that my d is 4, I could now actually do the exact same trick with 1 and 3, right? If I wanted a sub 1, I could say, oh, a sub 3 is a sub 1 plus 3 minus 1 times the common difference, which I now know is a 4, right? So that means 15 is a sub 1 plus 2 times 4 is 8. Oh, look, my a sub 1 is a 7. So that's a clever way to do it. So I get the same values, I get the same answer in the end, but that's a clever way to do it if what I give you are terms that are farther apart. Now, me personally, I always defaulted to doing this, right? No matter how many terms apart it was, I would draw these like gajillion of little lines, and it wasn't the fastest way, but it worked for me. And it's fine, but years ago, one of my students said, hey, wait, can't I take this formula and apply it in a different way and make this work? And it's totally true, you can, which is awesome. So you're not always going to see that. Sometimes you're going to go with a slightly slower option. As I said, I did it for years and it worked fine. But when somebody pointed out that this was another option, I thought, wow, that's super dope and really fast. So there you go.